Okay, so today's lesson is about simplifying rational expressions. It says it in the word. Now, I know you don't know what that means just yet. Before we get into that, let's go over a couple of rules, and then as we start going through the examples, the rules will make more sense. So, rules you want to remember. Whenever we're simplifying rational expressions, you can only simplify a monomial with another monomial. You can only simplify a binomial with another binomial. And you can only simplify a trinomial with another trinomial. All right. So as we get into our first example here, I'll explain better what that means. But you want to remember this. If you can remember this here, you shouldn't have any difficulty simplifying rational expressions. So let's take a look at our first example. So let's say I've got 8x. This is 3x plus 1, x plus 2, all over 12x squared times x plus 2 times x minus 1. All right. So, as long as everything is being multiplied together, you know, all this is a monomial being multiplied with a binomial and another binomial. This is a monomial being multiplied with a binomial and another binomial. So as long as they're all being multiplied together, we're allowed to reduce if things can reduce. And this is where the rule comes in. Right now, my 8x, since this is a monomial, I can only reduce it with another monomial. So I can't reduce the 8 right now with the 2. The reason is because the 2 is part of a binomial. You can never reduce the monomial with the binomial. Mono with mono, bino with bino, trino with trino. So my 8x is only allowed to reduce with the 12x squared because these are both monomials. So right now, those two could be reduced. 8 and 12, that would reduce down to 2 and 3. So if I'm writing my answer down below here, I'm already going to have a 2 and a 3. Check out the x's. I have an x here, and I have an x squared here. This x is going to cancel one of these, leaving me with just one x on the bottom, like that. All right, after that, now let's look over at the binomials. A binomial is allowed to cancel with another binomial only if they are identical. They have to be exactly the same. So right now, my 3x plus 1 can only cancel with another 3x plus 1. And there is no other 3x plus 1. Therefore, I cannot cancel this. My x plus 2, on the other hand, could cancel with the x plus 2 that's here. So these two would cancel each other out. And then I'm left with my x minus 1 down here. There is no x minus 1 on top. Therefore, there's nothing I can reduce it with. So I'm left with 3x plus 1 and then x minus 1. From here, there is nothing more you can reduce. I cannot reduce the 2 3's here because this is a monomial and this is a binomial. And you cannot reduce the monomial with the binomial. Try to fight that urge at times. All right, so this is as far as it can go. There's nothing more you can cancel. In case you're wondering, well, can I cancel the 1's because the 1's are both inside the binomials? No, you can't. Because remember, a binomial, it has to be identical to another binomial. You are never allowed to take them apart in pieces. I can't just go into a binomial and cancel one part with another part down here. That doesn't work. Either the entire binomial cancels or nothing cancels. All right, let's take a look at another example. So let's say I've got 15x cubed and 2x minus 7, x plus 3. And then here I got 40, x, 2x minus 7, and 3x plus 1. All right. So again, following our rules, I know I can reduce my monomial with my monomial down here. So These two can be reduced by 5, giving me a 3 and an 8. So I have 3 and 8. This x is going to cancel one of these up here, leaving x squared. After that, move on to my binomials. 2x minus 7. There is a 2x minus 7 down below, so I can cancel both those out. So this cancels that. On top, I have an x plus 3, but there is no x plus 3 down below. There is a 3x plus 1, but they're not the same. So these do not cancel out at all. So you're left with x plus 3 and 3x plus 1. And that would be your final answer. There's nothing else you can cancel. You can't cancel the 3x with the 3x because this is a monomial and this is inside of a binomial. All right, now let's add a little bit more to this. We'll start with simple problems today. Tomorrow we'll get more complex with it. So let's say we've got something like this. 6x squared plus 18x, all divided by 15x squared. All right. Now, in this case, we have nothing at the moment that can be canceled. On the top, this is a binomial. Don't look at it as if there are two monomials being added together. No. This is a binomial. This is a monomial. And we cannot reduce a monomial with a binomial. But what we can do, and this is what you need to do, you always factor first. After you're done factoring, then you're going to see what it is that can cancel. So I'm going to factor the top. On the top, I could take out a 6 and an x. So 6x, and then put parentheses. This will leave me with x plus, take a 6x out of here, and I get 3. So I factored the top. On the bottom, you still have 15x squared. Now that I factored the top, notice, now I do have a monomial on the outside. So I have a monomial that can reduce with this monomial. In this case, they can both be divided by 3. So this gives me a 2 and a 5. So I'm going to have a 2 and a 5. And I do have an x up here, and that x can cancel one of these x's down here. So I'm left with 5x. And my binomial, there's only one binomial in the whole problem, so this binomial cannot reduce with anything. So I'm left with parentheses x plus 3. And there is my final answer. Remember, you cannot cancel the two x's right now because this x is inside of a binomial and this x is part of a monomial. So they do not reduce together. Then let's say we got something like 4x over 8x to the 4th plus 8x to the 3rd plus 16x squared. All right. So again, we cannot start reducing yet. This is a monomial. This is a trinomial. I cannot reduce a monomial with a trinomial. But we're going to go ahead and factor it first and see if we have something after that. So on the bottom here, I could take an 8 and an x squared out of everything. So let's do that. If I take out an 8 and an x squared, I'll be left with x squared plus x plus 2. And then on the top, I still have my 4x. After that, now I do have a monomial up front, and it looks like that monomial will reduce with this monomial. So now we can reduce them. So my 4 would cancel, this becomes a 2. And I'm going to put a 1 here, because remember, whenever the top cancels, you got to leave the 1. You can't just get rid of the 1. This x here is going to cancel one of these x's down below. So I'm going to be left with, on the top, I'll have a 1. And on the bottom, I'm just going to have 2x. Because remember, this x here canceled one of these x's down here. And then you still have x squared plus x plus 2. And that would be your final answer. There's nothing more that can cancel. You don't have to multiply the 2x times this, leave it separate. This is the final answer. One more, you guys can get started on the guided practice. So let's say we've got 24x cubed. And then negative 12x cubed. Plus 6x squared. Minus 30x. All right. So on the bottom here, we got to factor this guy first. And remember, whenever the front term is negative, you're going to factor out that negative. So we're going to take out, looks like they can all be divided by 6. So we're going to take out a negative 6 and an x. Leaving me with 2x squared minus x plus 5. And then on the top, we still have 24x cubed. All right, from there, we can reduce the monomial with the monomial. So the 6 will cancel, this will become a 4. And this x will cancel one of these up here. So on the top, I'm going to be left with, what was that, 4x squared. Remember, it's going to become an x squared because this x here cancels one of these up here. My negative, you can leave the negative on the bottom, or if you want, you can put the negative on the top. It's actually considered proper to put the negative on the top instead of the bottom. You're still left with, on the bottom, 2x squared minus x plus 5. And notice, as long as there's nothing being multiplied times this, because everything that was being multiplied canceled out, and I put that negative on top. Therefore, it's not necessary to put the parentheses. It's not wrong if you do, you just don't need it. The only time you need parentheses is if something is being multiplied by it. If there's nothing multiplying, you can get rid of the parentheses. From here, go ahead and do the guided practice. And if you get stuck on anything, watch the video on the guided practice to help you out.